Once you've done a few exam questions with similarity, you'll start to realise most questions fall under the kind of same pattern in that you're given a couple of lengths on two different shapes and you're asked to either enlarge or reduce a volume, an area or a length, but it tends to be two lengths that are given. So you can see here in this example we've got 2 tins of soup mathematically similar. Volumes are shown in millilitres and it tells you the height of the larger can and asks you what the height of the smaller can is. Now, this is where it's different. Usually you would be given two lengths, and in this case you're given two volumes and you're asked for a missing height here. So a different layout to what's kind of common. So we'll go and have a look at what we've done over the previous few lessons on this and see if we can work out how to do this question here. Over the last few lessons we've looked at starting off with just scale factor for length. We then moved on to how to use that scale factor of length to find the scale factor for area, and then in the last lesson we looked at scale factor of volume from the scale factor of length. So really it's a case of how do we move back and forward between these values. So let's start off with our scale factor length up here, and how do we move across this to get from scale factor length to scale factor of area. And what you'll hopefully remember is all I need to do here is square it. So to give you an example, say for instance I put the number 3 here as my scale factor of length and I want to change that into the scale factor for area. All I would do is square that and that would give me 9. So what I want to look at now is what would happen if I was only able to work out the scale factor of area, and that would come from being given two areas that I could make into a scale factor, and I need to go back and find the scale factor of length. Now if this direction here, if we're squaring it, then this direction must be the opposite of squaring something. So the opposite of squaring something is to find its square root. So if we square it in one direction, we must be finding the square root of it in the other direction. So again, for instance, if the scale factor for area turned out to be something like 25, and I was interested in what the scale factor for length is, I would need to square root that 25, and that would give me a 5 there. If we now look at the bottom two here, where we've got scale factor of length and scale factor of volume, again, you'll remember hopefully from the previous lesson, if I was given the scale factor of length and I required to turn that into a scale factor for volume, all I would do is cube it. So we can write cube up here. So a for example for this would be, say for instance we had, let's use 3 again here, say the scale factor for length turned out to be 3. And I want to turn that into a scale factor for volume. Well, that would be 3 cubed, which comes out to 27. Okay, once we've done that, then we've got to ask ourselves what would happen if the question gives me two volumes, and therefore the scale factor that I create is a scale factor for volume. Then I need to be able to go back along this arrow the other way. So I'm asking myself, what's the opposite of cubing something? And I should know the opposite of cubing at this stage is finding the cube root or something. So on your calculator, remember that's the little button like this with the little 3 in the nook of the root symbol. If, again, for an example, we said we had a scale factor of, say, for instance, 64 for volume, and I want to change that back into a scale factor for length, then I would need to cube root 64. Now, the cube root of 64, you'd probably be doing that on your calculator, and the cube root of 64 is simply 4. So this is just the idea of how we move back and forward between the two of those. If you have the understanding of how to get from length to area and length to volume, then it should be easy enough to just perform the inverse operation and work your way back as well. So that brings us on to the question that we were going to do here. So looking back to the original question, again we've got our 2 soup tins. They're mathematically similar. The volumes are given in millilitres, so we've got a volume here of the small tin and a volume of the large tin, and it's asking me for the height of the smaller can, and it tells me the height of the larger can. So we know this height here, and we're really looking to put like a little X here and find this. So what I'm going to look at here is I'm going to start off by writing my scale factor. Now again, I need to understand, am I doing an enlargement or a reduction here? So I'm trying to find the height of the small can from the height of the large can. So what am I trying to do with this 14? Am I trying to make this 14 larger or smaller? And you can see it's on the larger can, so I'm trying to reduce the size of this. So it's a reduction scale factor. So we'll start off with writing out reduction scale factor. And what I need to be careful of is I understand what am I going to put in here. Now, the things that have gone in these brackets before are either length, area or volume. My scale factor in this case is going to be made up with two corresponding volumes. So the scale factor I get if I use this volume and this volume will be a scale factor for volume. So we'll put in the word volume in here. Now again, it's a reduction, so we need to make sure our fraction is less than 1, otherwise it would be an enlargement factor. So taking the numbers 250 and 400 here, I need to make it 250 over 400. Now, just like in previous questions, I need to be careful here. I know this is the number I'm going to have to multiply by a reduction scale factor because I'm trying to take this 14 and reduce the size of it, but this is a length, so I can't reduce this using a scale factor for volume. I'll need to have a reduction scale factor for length. So I'm going to write that out, reduction scale factor for length. And we're going to try and remember how we did that. So remember, when I wanted to go from length to volume, I would cube it. So to go from volume to length is the inverse of cubing it, which is going to be the cube root. So I'm looking for the cubed root of, so a small little 3 in there. Keep that in brackets for your calculator. That's really important that has brackets around it. And we'll close the brackets there. So this is now a reduction scale factor for length, which means I can actually use it, because it's a reduction scale factor for length, I can use it to reduce a length. In other words, reduce this 14 here to find my height of the smaller can of soup. So height of smaller can is simply the larger can of 14 multiplied by my reduction scale factor for length, which from above is the cubed root of 250 over 400. Now this might look quite cumbersome, but remember your calculator is going to do all of the work here, so we can type that in, just making sure that you know how to type that into your calculator properly. So we should get there 11.97, and that is going to be centimetres because it's a length. It's really worthwhile just making sure that you pause the video here and just double check you can actually put this into your calculator correctly and get this answer.